Hello friends, I've come up with the first video, my question solving series, question series. Okay, I will solve just one question, study everything related to it, and इस concept से related और क्या question बन सकता है. So let's see. Cantilever beam of span L is built in at the support. Built in means fixed and supported, right? Fixed and supported. Now it is restrained against lateral deflection, okay, and torsion at the free end. The effective length of compression flange for the beam, as per IS 800 2007, IS 800 2007, right? So ऑप्शन में है 2L, 0.85L, 5L एंड 0.75L और आंसर क्या दिया है? ये क्वेश्चन है SSC JEE 2020 मॉर्निंग शिफ्ट, राइट? तो लेट्स सी पहले कि लैटरल डिफ्लेक्शन या टॉर्शन बीम कैसे दिखती है कैंटिलीवर. तो कैंटिलीवर है एक, ये डायग्राम में, और इसमें क्या हो रहा है? इसमें टॉर्शनल बकलिंग हो रही है, ठीक है? तो दिस इज द बीम इज गेटिंग फेसिंग टॉर्शन, ठीक है, अबाउट इट्स लॉन्गिट्यूडनल एक्सिस, about its longitudinal axis, right? There is longitudinal axis of the beam here somewhat. This won't be visible. I've just drawn to make you visualize. Okay. So this about longitudinal axis is undergoing torsional buckling. So now let's see what is the relevant clause in IS 800. So this was the clause, clause number 8.3.3 for cantilever beams of projecting length L. Okay, the effective length LLT to be used shall be taken as in table 16 for different support conditions. Right. So in our question, what was the condition given? So it is restrained against lateral deflection and torsion at the free end, and it is built in at the support. So let's first go to our question. तो lateral restrained laterally, यहाँ पे देख रहे हैं आप, this is built in support, then this is restrained laterally and torsionally and against rotation on the plan. Okay, so laterally कोई deflection नहीं होगा, the beam will not deflect laterally anywhere in these directions. Okay, and there is no torsion, it will not undergo any torsional buckling. Okay, and against rotation also. So this is the plan. Suppose beam हम top से देख रहे हैं, so it will be visible like this. So plan में भी कोई rotation नहीं होगा. Okay, this is the cantilever beam. Here it is fixed here, right? It's fixed here. So plan में कोई rotate, यहाँ पे rotation हो रहा है in this case. So this rotation won't take place in our case. So इसमें तीन conditions, four conditions are there. This is restrained condition at support, and this is restrained condition at top, right? So restrained condition at support में क्या है? Restrained laterally, torsionally and against rotation on plan. तो यहाँ पे कुछ भी नहीं होगा, ना lateral deflection, ना torsion या ना rotation in plan. But at top, first case is free. At top it is free. Okay, free है, laterally भी deflect हो सकता है और torsionally भी sway हो सकता है. तो उस केस में अंडर नॉर्मल लोडिंग कंडीशन एंड देयर इज अनदर डीस्टेबलाइजिंग लोडिंग कंडीशन, इसको भी हम देखेंगे लोडिंग कंडीशंस. तो अंडर नॉर्मल लोडिंग कंडीशन फ्री में जो है 0.8L है और डीस्टेबलाइजिंग में 1.4L. इज नॉर्मल, राइट, एंड दिस इज डीस्टेबलाइजिंग. And then lateral restraint to top flange, just the top flange, यहाँ पे उसको lateral restraint दिया गया होगा, ठीक है. then उस केस में क्या होगा? 0.7L under normal loading condition and 1.4L under destabilizing loading conditions. and torsional restraint है टॉप पे, राइट? टॉप पे टॉर्शनल रिस्ट्रेंट है, सो ये टॉर्शन में बकल नहीं करेगा, ये बीम बकल नहीं करेगा. ओके, सो इस केस में क्या होगा? 0.6L एंड 0.6L सेम रहेगा. इन लैटरल एंड टॉर्शनल रिस्ट्रेंट, लैटरली भी अपने पोजीशन से स्वे नहीं करेगा और टॉर्शनल रिस्ट्रेंट बीम रहेगा, जो हमारे क्वेश्चन में था. Our question was dealing with this point number 4. So in this case, what will be the effective length under normal loading condition? It will be 0.5 L, and it will be again in destabilizing, under destabilizing loading condition also it is 0.5 L, right? So because they have asked this one, in 2020, they might ask some other condition. So let's see all of them. So first understand what is the normal and destabilizing loading condition, or even जब destabilizing loading condition आ रहा है, this is the critical case, right? This is the critical case. और जब critical case होता है तो हम जो effective length है उसको increase कर देंगे so that the load permitted to be applied this P, ओके, वो कम हो जाए, ठीक है. सो इस वजह से यहाँ पे 0.8 L है, यहाँ पे 1.4 L, यहाँ पे 7.7 L, यहाँ पे 1.4 L, यहाँ पे 0.6 L, यहाँ पे 0.6 L, बिकॉज यहाँ पे टॉर्शनल रिस्ट्रेंट है, ठीक है, और कंप्रेशन फ्लैंज मूव नहीं करेगा. तो दिस, इन दिस केस, this is pretty much the same condition. So let's understand what is the uh, destabilizing loading condition. So suppose this is the I section, the beam we are using of I section. So there is shear center. Okay, this so shear center, अगर लोड shear center से पास नहीं हो रहा, ठीक है, there is some eccentricity, right? Suppose EX है, तो ये क्या करेगा, एक clockwise couple form करेगा, and this is destabilizing loading condition. And suppose there is stabilizing loading condition also. Okay, so there is beam is buckling, swaying this side, okay, and यहाँ पे जो मोमेंट है वो इसको स्टेबलाइज कर रहा है. So this is destabilizing loading condition. So destabilizing loading condition because the vertical load has moved with the compression flange, which is deflecting laterally. Okay, so compression flange is deflecting laterally और जो vertical load है उसी के साथ move कर गया. Then it is destabilizing loading condition. The vertical load is eccentric to the shear center and the resulting moment encourages further lateral deflection of the beam. और इस वजह से ये critical case है because it is further adding to the lateral deflection of the flange, that is compression flange. ठीक है, तो इस वजह से फिर इस केस में हम क्या करते हैं, the longer the compression member becomes for the same cross section, the greater becomes its tendency to buckle and smaller becomes the load it will support. इस वजह से हम जो इफेक्टिव लेंथ ले रहे हैं वो क्रिटिकल केस में हम उसको इंक्रीज कर दे रहे हैं so that the load permitted gets decreased. Okay, load becomes smaller, right? So now moving on to other conditions, other restraint conditions, like there is continuous at support, the cantilever is continuous. Okay, so these are two beams, beam number 1 and this is beam number 2. तो हम 1 की बात कर रहे हैं यहाँ पे, वी आर टॉकिंग अबाउट 1 में यहाँ पे दिस टॉप बीम इज रेस्टिंग ओवर, टॉप बीम 2 इज रेस्टिंग ओवर टॉप बीम 1. ओके, एंड इसमें ये वाला जो लेंथ है, दिस लेंथ, if it is not visible, let's see. So this length is what we are considering as cantilever, ठीक है, this part. So यहाँ पे क्या है, at top first condition is it is free, ठीक है, free to laterally deflect, free to torsionally buckle, okay, everything is free. तो इस केस में हम नॉर्मल लोडिंग कंडीशन में कितना इफेक्टिव लेंथ दे रहे हैं, दैट इज 3L, where L is this length, okay, length under consideration. And for destabilizing loading condition it is 7.5L, right? Then lateral restraint to top flange, lateral restraint दे रहे हैं किसको, top flange को, just the top flange, this is the top flange, right? तो इसको हम lateral restraint दे रहे हैं सब. so इस केस में क्या होगा, टॉप फ्लैंज फ्री नहीं होगा मूव करने के लिए लैटरली. तो इस केस में नॉर्मल लोडिंग कंडीशन में 2.7L and this is 7.5L. So again these both are same, just under normal loading condition the effective length is changing, 3L and then 2.7L, right? And then torsional restraint अगर टॉप पे दे रहे हैं, टॉप पे torsional restraint भी दे दिया, ठीक है, देन उस केस में क्या होगा, then normal loading condition में 2.4L, then this is 4.5L. And under lateral and torsional restraint it is 2.1L and 3.6L. तो अगर destabilizing loading condition को consider ना किया जाए, suppose, because uh, it has not asked in examination till now, so considering just the normal loading condition, so this is 3L, then decrease किया 0.3 से minus 0.3, right? Then 2.7L, then minus 0.3, 2.4L, minus 0.3, 2.1L. So this can be the way to remember it. Then coming on to, this is continuous. Beam is again continuous with partial torsional restraint. तो यहाँ पे कौन सी बीम की हम बात कर रहे हैं? We are talking about this beam number one. There is beam number two, and beam one is resting over beam two. So uh, it has partial torsional restraint. Okay, so just the bottom flange of the beam one, the beam under consideration, is suppose welded here. There is something like welding here. So just the bottom flange is restrained. Okay, and the top flange is free. Here the top flange was had lateral restraint at the support. Okay, because these beam two was resting over beam one, but here it has partial torsional restraint also. Okay, this is bottom flange. So again, at top the condition is free. First case, so it is 2L. Okay, then lateral restraint to top flange. Lateral restraint to top flange को lateral restraint दे दिया. It will not deflect laterally. Then 1.8L, again torsional restraint to top flange. Okay, torsional restraint to the top पे जो है torsional restraint दे देंगे. It will not undergo torsional buckling. So इस केस में 1.6L, then lateral and torsional restraint 1.4L. Again there is hint minus 0.2L का. ठीक है, so here it was minus 0.3L, 3L, 2.7L, 2.4L, 2.1L. Here 2L, 1.8L, 1.6L, and 1.4L. Right. Then the C condition, continuous with lateral and torsional restraint. Lateral and torsional restraint at the support. ये support के लिए. So you can see beam under consideration is beam number one. Beam number two पे rest कर रहा है. And there is welding of the bottom flange of beam one. Okay, and again there is a member steel plate, okay, of a I shape that has been welded. So there is lateral restraint also, because this ये lateral restraint provide करेगा, okay, at support. So again at top अगर free है, ठीक है, other than at support, अगर at top the top flange is free, then 1L, okay, then 1L. Then under normal loading condition, again the normal loading condition, the destabilizing loading condition we are not memorizing. Okay, then lateral restraint to top flange को lateral restraint दे दिया, it will not deflect laterally, then 0.9L. Again torsional restraint to the top flange, top की बात हो रही है, this is for top, right? So again this is 0.8L, and lateral and torsional restraint both to the top. So lateral and torsional restraint both, again it will be 0.7L. So again here 0.1L से decrease हो रहा है. So and the D case जो हम पढ़ चुके हैं, इसमें भी 0.1L से decrease हो रहा है. So one case it was decreasing by 0.3L, then 0.2L, then 0.1L, and again last one also 0.1L. So just remember the first one free, and remember all the other cases. Okay, then free, then lateral restraint to top flange, then torsional restraint, and then lateral and torsional restraint. And we are talking about top in this case. Okay, so this is all about this question. So correct answer definitely will be, जो आंसर दिया था, that one is correct. It will be 0.5L. We have covered others also. So you can revise this one from table 16. Table 16 of IS 800 2007. The clause number is 8.3.3. Okay. So thanks all for watching this.